Okay, so today we'll be doing past paper, May 2008 for mathematics, that is, CSEC past paper. Now I'll be drawing the answers. So we'll be looking at question 1 and question 2. So this that I'm looking at is question 1A. Right? So using a calculator or otherwise, evaluate each of the following, giving your answer to only 2 decimal places. So as you see here, 73.18 minus 5.23 times 9.34. Now, as you would have known, the very first thing that you do when you see 2 different operations, as you see a multiplication operation, and take note the asterisk will be used for multiplication, right? So you see 2 operations, you see subtraction and you see multiplications. Now, anytime you see these 2 together, you know that the multiplication is supposed to happen first, right? So let me add oops, change that right there. Yeah, let me add the parentheses, right? So that would signify that that operation happens first. Good. So let us work on that operation. So when I put in the calculator, and you can use your calculator for this, 5.23 times 9.34, I get 48.85. So always seek to put your operations to 2 decimal places at least, or even 3, to give a little more accurate response. Good. So 48.85 is the answer, right? I'm just rounding it off, good, to 2 decimal places. And of course, we're going to put back the 73.18 minus, good. Yeah, oops, it's a little far. Let me add it there. Yeah, minus. Let me clear it to make it a little more. So therefore, this would then give us equal to putting in the calculator 73.18 minus 48.85. Now the answer that you're supposed to get is 24.33. Good. And as you know, this is up to 2 decimal places, so that's the answer that you're actually supposed to get, right? Now, in this operation over here, right, you have 3.1 squared over 6.17, good, plus 1.12. Now, as I said before, operations such as multiplication and division has to be done first. Good. So let us have a separate thing over here for that. So we would have 3.1 times 3.1, right, divided by 6.17, right? And all of that is added to the 1.12, right? Let me proceed to add the parentheses. to know that it's a different operation, and that would be happening first. Now what I am going to do is that I am going to square the 3.1 first and then divide it by the 6.17. Now when I square the 3.1, I get 9.61, right? And that would be divided by the 6.17. May add that little space here. And of course, that would be added to the 1.12. And don't say 1.12, because once it passes the decimal point, you count it as single digits, not as double digits to say 12 or 34. No, 1.112, right? So when I did this operation right here, 9.61 divided by the 6.17, I got on the calculator 1.58, right? So I'm putting it to 2 decimal places. Sorry, 1.56. Yes, that's what I get. No, it's equal to 1.56. Good. And that 1.56 would be added to the 1.12. Thus, this would give us the answer of 2.68, right? Good. So this, let me put it there. I always like to do this to signify that it's the end, right? So that is the answer. So let me use my spotlight here. This would be the answer, 2.68. And of course, you know that is to 2 decimal places. Normally, when they ask in the question paper, to make the answer into 2 decimal places, I often like to work out the question using 3 or 2 decimal places to make it easier at the end, right? So let me do a quick run through to these 2 questions, and then we can move on to question 1B. Now, remember that the rule is we have the multiplication happening first. Anytime the addition, subtraction, multiplication, division, always put the multiplication and the division, always work those questions first before you go and work the subtraction part of the question. So oftentimes what I love to do, as I've shown you guys before, I love to add my parentheses or brackets, as you want to call it, to kind of separate the question, the equation, right? So see, I've added the brackets. When I multiply the 5.23 by the 9.34, I got 48.85. And that is what I subtracted from the 73.18 to get this answer right here, which is 24.33. And that is the answer to 2 decimal places. And recapping through AII, right? 3.1 squared plus 1.2, I'm sorry, 3.1 squared over 6.17 plus 1.12, right? So if you notice, what I did, I worked out the squared equation first. So normally when you see squared or cube is when you have the 3 up top here, right? So normally when I have those operations dealing with, I like to deal with them first, since they're more complicated. And imagine if I actually divided before I squared the number, that would be a lot complicated. So I ensure that I square this number before I do the division. That is what I love to do, to make life easier. So when I square this number, I got 9.61. right? And then I proceeded to divide it by the 6.17, and of course we got 1.56, which is then added to the 1.12, and we got this answer, which is 2.68, and that is to 2 decimal places, right? So if you notice everything that I did, I actually worked it out in 2 decimal places before to make it a little easier going back, right? Now guys, now let's continue. Now this is question B from question number 1. Now Jenny works at Sammy's restaurant and is paid according to the rate on the table. In a week, when Jenny serves N customers, her weekly wage in WJ in dollars is given by the formula WJ equals 600, which is dollars, plus 0.90 N, right? So let us look at the table, because it's saying that it's paid, Jenny is paid according to the table. Now, first we need to set out what we are our steps and our basic information, what we know. So Jenny's weekly agreement is that she gets $600 for the week. That's the basic wage. And for every customer served, she gets 90 cents, right? Which is same thing as $0.90, same thing, right? For every customer served, that's the amount that she gets. Now that would add up to the formula to be 600 plus 90 cents, basically 0.90 N, because remember that N is the amount of customers. So therefore, if we want to figure out how much you would get in all, then we would have to multiply this 0.90 in order times the N, that's times the amount of customers, in order to get the answer, right? Now, let's say that she served 2 customers for argument's sake, right? Let's say she served 2 customers. Then you would have 600 plus 0.90 times 2. Because remember that normally when you see 2 characters together, it normally means that it's multiplied, right? Like these 2. Good? So it's 0.90 times 2, because 2 customers that she served. What if she served 20 customers? Right? Then we would say 600 plus 0.90 times 20, because 0.90 or 90 cents is the amount that you get for each customer. So anytime you have a certain amount of customers, then you will multiply this number by the amount of customers, right? And you'll get that answer. And of course, in order to get the whole pay, then you would have to add it to the 600, because 600 would be the basic wage. Now the question goes on further to say, determine Jenny's weekly wage if she receives 230 customers. Now remember, what's the principle? What do we know? We know that for each customer served, we get 90 cents. So therefore, if we have a certain amount of customers, then we know that we'll multiply the amount of customers by this number. That's the basic thing to keep in mind. Good? Now that is basically what question 1 asks for. Question I asks for. And don't forget to add it to the 600, because 600 is the basic wage, right? So of course, we're going to apply the formula. Good? And say, first, write your equations. 600 plus 0.90 N. Always write the formula, right? Equal WJ. right? Good. Always write the formula. Keep that in mind. Good. Now, she served 230 customers. So therefore, where would that number go? Of course, that number would go to multiply, right? That number would go to multiply with the 90 cents, right? Because remember that 90 cents is for each customer served. So therefore, you would multiply the amount of customers by the 90 cents, right? So therefore, 230 customers. And of course, I like to draw in my parentheses, right, to separate, because remember that oftentimes when we're dealing with operations, multiplication always occurs first before addition. Good? So of course, let us put in our 600 plus, and let us multiply the 0.90 by the 230, right? And of course, we get 207, right? So the 600 by the 207 is equal to $807. Now, after all of this, I always like to write a statement. You know, CXC likes when you show, the answer, the direct answer when you're clear. So you have therefore, Jenny would receive, right, $807 for that week. Good. So that's the amount that she would receive, right? So moving on. Now this question says, in a good week, Jenny's weekly wage is $1,000 or more. Take note of this, $1,000 or more. So it means then this is the least amount she would get in a good week. Good. Now, what is the least number of customers that Jenny must serve in order to have a good week? Right? So let's work that out, friends. Good. Now, first we need to establish something. $1,000 is the least amount that she would get in order to say that she had a good week, right? So therefore, let us think about it, right? We need to we need to find out the amount of customers for the 1,000. But guess what? Let us start the process by writing the formula. 600 plus 0.90n. That is the general formula that we know of. Good. Now, in order to have a good week, she must have at least $1,000. So therefore, it means that it should be $1,000 or more. Now I know that you guys, so let us write the formula then. Let me put the 1,000 here. I'll leave the sign for later. Good? Now, I know that you guys will say that you're writing the formula and you will be writing the equal sign. No. Good? No equal sign should be used. Now think about it. It is $1,000 or more. So therefore, its number has to be greater or should be 1,000. So therefore, the number should be greater than, let me try to write this properly. The number should be greater than or equal to 1,000 because it says 1,000 or more. Let me say that again. Now, the first thing that we would do is that we would write our formula, which is 600 plus 0.90 n. Now, it asks, in order to have a good week, Jenny needs to get at least $1,000. Now, instead of writing the equal sign, right, we know that 1,000 is the least that she should get. So therefore, she should get greater than, because of course, you're expecting more. Good, more than the 1,000. So greater than or equal to 10 because the question says at least 10, right? So you may want to rewind 10 seconds or so if you want to, if you are not quite clear, right? So that is the essence of it. Good. Now, the reason why I say this, we don't use the equal sign because if we use the equal sign, then we're trying to equate it to 1,000. And Jenny does not, in a good week, Jenny does not only get 1,000. So think about it. Say a situation wherein your parents give you $1,000 for your lunch money. Good? Now you would say you get a good lunch money when you get $1,000. And it even better if you get more, right? So if you equate it to, if you say equal 1,000, then you would be saying that, you know, $1,000 for my lunch money good enough. And then it's like you will be saying that $2,000 is not good because it's not 1,000. You get what I'm saying? So once is greater than 1,000 or 1,000, or you could also say at least 1,000, then you know that is greater than or equal to 1,000. That is how we would get that. And the question comes further to ask, what is the least number of customers that Jenny must have in order to have a good work week? Now, I'm going to use my sketching for this. Now, the simple operation that we would first do here, of course, is that we, in order to get to find n, because n is what we're trying to find. We're trying to find the number of customers, and remember that the number of customers is represented by n. Good? No, we need to get rid of this because this is in the way because we're trying to make n the subject. So therefore, this we need it to come over here soon. Good? Good. Now, therefore, we would subtract 600 by both sides. When we subtract 600 by both sides, then we would get 0.90n greater than, well, I can't write the sign at the moment, I'd have to draw it, greater than or equal to 1,000 minus 600. Good? Let me join the sign. Good? Don't mind my sign, right? I know it won't be perfect, right? So just get the essence of what I'm saying. Good? Now, therefore, that would make this 0.90n greater than or equal to 400. Good? Good? Now, the next step, of course, we know that if you realize we have this multiplied by the n, and we want n to be the subject. So what do? We get rid of the 0.90, right? So we would divide it by both sides. Good? We divide it by both sides. So 400 divided by 0.90. 0. Good. And the answer that we get here, we actually got n equal 444.4. Now, this is where the trick comes. Good. This is where the trick comes. Now, when I go into my calculator and I multiply 444.4 times 0.90, I get, and of course, adding the 600, I get 999.96. Now, this figure that you're given here, notice that it's less than. Good? Notice something. This figure that you're given here, it's the amount that, of course, can be divided into 1,000, right? So therefore, it means that this number would be less. Now, if we were, imagine, say it was an even number, and there was no, well, not an even number, but say it was a whole number, right? And it had no decimal place. Then we would proceed and say that 444 is the answer. However, it has a decimal place. And of course, we don't have decimal places when it comes on to customers, right? And of course, we cannot get rid of the 4, because if we get rid of the 4, we would actually we'll be actually saying a less number, right? We'd be saying it's less if we round it to 444, right? Now, therefore, it means that we would have to put it to 1. We need to add 1, so it would be 445 customers. Let me go through that again. Good. No, we cannot say that we have n, right? We say the answer after we divided everything and worked out everytheverything, we got 444.4. We cannot say decimals when it comes on to customers. They're people. You cannot have 0.4 of a person. No. Now, when we're rounding this off, notice that it's lower than 5. So, of course, you would need to round it to the lower side, right? Now, since we're rounding it to the lower side, then we would get less customers than what would be required for the 1,000. Good. So let's say we got rid of this and we say 444. When I multiply the 444 by the 0.90, and of course adding the 600, I got less than the 1,000, simply because you're rounding down, you're doing something less, right? And that would not be a true reflection. So of course you need to add one more to it, right? And that would say that at least that amount of customers would need to come in order for it to be a good week, right? Moving on. Okay, so I know. 3. At the same restaurant, Shauna is paid a weekly wage of $270 plus $1.50 for each customer she serves. If WS is Shauna's weekly wage in dollars, write a formula for calculating Shauna's weekly wage when she serves M customers. Now, let me get my flashlight here. Now, anytime you're working out a question or writing an equation for a question, you'll always have to think what you're given. So first, what is the basic wage? $270, right? What is the amount for each customer? $1.50. Good. Now, in order to get the weekly wage, what do you have to do? According to the question, $270 plus that amount for each customer. And what is the code? What is the symbol that symbolizes the customers? M. because it says she serves M customers. That's the amount of customers. Good. Let me go again. What are you given? First thing, what is the basic wage? $270. Next thing, how much per customer? $1.50. Next thing, how many customers? M. Good. She serves M customers. Put them all together. $270 plus the $1.50, right, times the amount of customers, just as how we have here. Because for Jenny's work weekly wage, her wage was $600, and then she got 90 cents per customer, and she had N customers. The same thing applies here. So thus, the formula would be 270 plus 1.5. You don't have to put the 0 because it's the same thing, right? 1.5 M, and that's equal to WS. Now, please bear in mind the J and the S right here, they're subscripts, right? So, you know, they're the little things at the bottom. Good. Now, the next question says, in a certain week, Jenny and Shauna received the same wage for serving the same number of customers. They served the same number of customers. Now, how many number did they each serve? Now, let me get my spotlight. First thing, what are you given? What are you given? That's the thing that we need to get in our minds. Now, the key term, let us read the question once more to see if we get a better understanding of what the question is actually saying to us. Now, in a certain week, Jenny and Shauna received the what? The same wage. The same wage. What is the wage? The wage is everything added up together. This is the wage. Everything right here is the wage, right? The basic wage plus the amount of customers. That is the total wage, right? Now, therefore, if the question says that Jenny and Shauna receive the same wage, the first word that should come to your mind, they are equal. They're the same. There's no difference, right? So that would lead us to, therefore, write or equate. They're equivalent. They're the same. Good? So therefore, you're going to put them together. So we're going to put Jenny's wage is equal to Shauna's wage, right? Let me write that statement. So Jenny's wage equal to Shauna's wage. Good? That's the basic idea that we should have into our heads. Let me go again. Now, in a certain week, Jenny and Shauna receive the same wage, meaning that it's equal, right? For serving the same number of customers. So therefore, if they both serve the same number of customers, then you get one number. Good? To signify the amount of customers. And we would like to say that they receive the same wage. So therefore, Jenny's wage is equal to Shauna's wage. What are the wage? The two equations represents the wage, right? Good. So let's write these two equations. So over here, you have Jenny's wage. What is Jenny's wage? Jenny's wage is $600 plus the 90 cents N. Good? That's what we establish, right? So let's equate it now to Shauna's wage, which is 270 plus, oh Lord, I put equal right here. Let me deal with that. Yeah. Me deal with that right there. Yes. Now, Shauna's wage is what? $270 plus $1.50. You don't have to write the $1.50. You can just write 1.15. Sorry, 1.5. Right? You don't have to write all of it because, of course, they would be in the same thing. But however, for, I'll be using both digits. So 1.50 times n. Right? So that is their wage. Good? And they are equal. No. We would then proceed to work this out, right? Now let us look at the equation. And let us observe the equation. Now, what is the main goal? To find out the same amount of customers, meaning that one number would be given. One number would be worked out. We would get only one number. So therefore, in order to work out this equation, we would then have to put the like terms together, right? The like terms together. Now, you may be wondering, why did I put n here? Why did I put n here? Now, the reason why I put n right here is because we want to establish an equal amount. Good? So we said that it's equal, this equation is equal to this equation. And of course, we want to better able to work out the equation. So it would not necessarily matter. Good? Once we know that the principle is still the same. Good? Now we put the like terms together. So this would go with this would go with this. Let me work it out right here. So of course you will have whichever way you want to put it, it doesn't matter. It will give you the same answer. Good? It will give you the same answer. Good? So we would want to maybe say 600 minus 270 equal, right? 1.5 n. Good. We want the terms to be like terms. So that's why I changed the m to n, right? Because we want it to be like terms in order for it to be feasible, right? So 1.5 n minus the 0.9 n. Good. What we get right here? 600 minus 270 is what? 330, right? So 330 is equal to 1.5 n minus 0.9 n is what? That is 0.6. 0.6 n. Now, this is where we're familiar with. Let me add a little line right here to kind of separate everything. Good? Now we reached a place that we're familiar with. Let me rewrite it over here. 330 is equal to 0.6 n. Now, what do we want to make the subject? What is the customer? What represents the customer? The n. So therefore, we want to make n the subject. So when we want to make n the subject, of course, we want to get rid of the 0.6. So how do we get rid of the 0.6? It's multiplied to the n. So we divide 6 by both sides. We divide 0.6 by both sides. So I'm going to proceed. Let me just draw it. Right? So 0.6, 0. Oops. 0.6. Good? Bam, bam. Good? So therefore, n is equal to 550. So you could write in your statement, therefore, they both served, right, 550 customers. Good? So that's the amount that they have served. Now let's move on to question number 2, right?